Hello everyone and welcome to Kiru's online lectures. I am Kiraj Chamtani and today's topic is Geometric Progression Part 3. See, in Part 1 we discussed Introduction and General Term of the GP. In Part 2 we discussed selection of the terms in GP and sum to n terms of GP. Now in this part, in Part 3, we are going to study the sum of an infinite GP and how to insert the geometric means between the GP. So coming on to sum of an infinite GP, let's suppose I am provided with a GP A1, A2, A3 and this GP is infinite GP. So where the first term we'll consider A. So when we are provided with infinite GP, the sum of n terms comes out to be A upon 1 minus R. Note, when we are talking about infinite GP, the sum of an infinite GP tends to infinity. So if R is greater than or equals to 1, then the sum of an infinite GP, it tends to infinity. So thus we can say the sum, basically when we are provided with infinite GP, so the sum is given by the formula which is A upon 1 minus R. Coming on to question, we have to find the sum of an infinite GP minus 5 by 4 minus 5 by 16 minus 5 by 64. So over here in this GP, A is minus 5 by 4. R, common ratio, second term divided by first term, the common ratio is minus 1 by 4. Now over here, what we take mod of R only. So mod of R, if we see over here, that is 1 by 4 and that is less than 1. So therefore over here when we calculate sum of an infinite GP, the formula is always A upon 1 minus R. It is never R minus 1. That is A upon R minus 1. So putting these values over here, minus 5 by 4, 1 minus 1 by 4. So we'll get over here, since mod of R is this, but the value of R will put minus 1 by 4 only. So when we'll solve it, so here we'll get minus 1. That is, this formula is basically based on mod of R is always less than 1 only, but this R will put here the negative sign also. Negative sign only. We won't ignore the negative sign because in formula we are not having mod R. So usually when we are calculating sum of an infinite GP, mod of R is seen and because of that only this formula is applied. Coming on to next question, the next question is we have to prove that 6 ki power 1 by 2 into 6 ki power 1 by 4 into 6 ki power 1 by 8 and so on till infinity, the value of this is equals to 6. So clearly 6 ki power 1 by 2, these bases are same. So this can be written as 6 ki power 1 by 2 plus 1 by 4 plus 1 by 8 and so on till infinity. So as we see over here, this particular series is in GP. So obviously for this series we will apply formula. So the formula will be A, that is 1 by 2, 1 minus R. So R is over here, again it is 1 by 2 only. So when we will calculate it, it is 1. Thus the value of this, which is in power, it comes out to be 1 only. So 6 ki power 1. So it can be written as 6. Next question is, the first term of GP is 2 and the sum to infinity is 6. So we have to find here common ratio. First term, that is A, is 2. Sum to infinity, that is S infinity, is 6. we have to find common ratio, that is r. So S infinity is a upon 1 minus r. S infinity is 6 upon 2 upon 1 minus r. So this is equals to 6 minus 6r equals 2. So thus when we'll shift over here, so we'll get 6r equals 4. So value of r will be 4 by 6, which is 2 by 3. So this is how we understood the concept of what is sum of infinite GP, and we solved questions related to it. Now coming on to next topic, which is insertion of geometric means. Now let's suppose I am provided with the two numbers a and b. So I have to insert geometric means over here, that is g1, g2, g3 and so on till gn, these are inserted. So when we insert these numbers, so total numbers, that the total terms comes out to be n plus 2. So thus, as we know, the formula of GP is an o is equals to a into r ki power n minus 1. An is b, this is a only. R ki power n can be written as n plus 2 minus 1. So thus we'll get b is equals to a into r ki power n plus 1. So thus the value of b by a is r ki power n plus 1. So this can be written as, the value of r can be written as b upon a ki power 1 upon n plus 1. So this is how, if we have to insert some geometric means, we'll calculate r, and since we are provided with a and b, so then we'll calculate the geometric mean. Now again we have two terms. Now over here the single geometric mean is inserted. So when single geometric mean is inserted and we have to find the value of that geometric mean, so we'll only apply formula. As we know, this is a GP, it is a geometric progression, so we can write g by a is equals to b by g, because the ratio will be same. So g square is equals to ab, so value of g will be square root of ab. So this is how we can find one single geometric mean between two numbers, and this is, we can find any, like if they have said 7, 8, any of the geometric means we can find out by this formula. Coming on to question, we have to insert 5 geometric means between 576 and 9. So we are provided with 576 and 5 geometric means, that is g1, g2, g3, g4 and g5, and last term is 9. So value of n is 7. As we know the formula, r is b by a, 9 by 576 power 1 upon n plus 1. So how many geometric means we have inserted over here? That is 5 geometric means we are inserting over here. So therefore the n is 5 plus 1, because 5 geometric means we are inserting over here. So these 5 will see over here. So the value of n is 5. Thus when we'll calculate it, the value of r will come out to be 1 by 64 ki power 6. So 1 by 6. So this can be written as 1 by 2. Now we have got the value of r. Now g1 is, it is a2. So a2 is written as ar, which is 576 into 1 by 2. 576 into 1 by 2, which is 288. Similarly g2 is ar square, 576 into 1 by 4, which is 144. g3 is ar cube, 576 into 1 by 8, which is your 72. Similarly g4 will get 36 and g5 will get 18. So this is how we can find out the number of the geometric means, how many geometric means we have inserted. Like we have inserted 5 geometric means, we can find out their values by same method. Coming on to next question. So the next question is, we have to find two numbers whose arithmetic mean is 34 and geometric mean is 16. Arithmetic means a plus b by 2 is 34. Geometric mean, which is square root of 2, square root of ab. So square root of ab is 16. So thus a plus b can be written as 68 and ab can be written as 256. Now as we know, a minus b whole square is equals to a plus b whole square minus 4ab. So here we'll find a plus b, that is 68 square, minus 4 into, sorry, this is 256 because 16 square, 4 into 256, which comes out to be 3600. This is a minus b square. So a minus b will be 60. Now a minus b is 60 and a plus b is 68. When we'll solve these both equations, we will get a is equals to 64 and b is equals to 4. So this is how we have studied today, how to calculate sum of an infinite GP, and how to calculate the value of the geometric means, and also how can we correlate arithmetic mean and geometric mean, and we can solve the questions. Hope you guys are finding videos helpful. So do like, share and subscribe the channel. Thank you.